me know in the chat section. I've just enabled the chat. Please let me know in the chat section whether you're able to hear my voice and see my screen. Okay, thank you, Abhijit. Thank you, Rakshita. Okay, that's amazing. Okay, thank you so much, guys. And I can see few learners are still joining in. Let's give couple more minutes. Like I'll give you 1 more minute for the learners to join, guys. In the meantime, if you have got any question, please do let me know. So let's give another minute. And just to reconfirm, guys, so you have received an email with the class link as well. Am I correct? I hope everyone has received the email with the class link. Okay, thank you, Abhijit. Okay, Darshini, Sangeeta, okay, Kavya, Ramesh. Okay, that's great, guys. Okay, so all right, so let's begin our learning journey. Now, I'm just checking I'm doing one round of final check. All right, so let's get started, everyone. So welcome everyone to this AWS Certified AI Practitioner Instructor-led Bootcamp for your examination preparation. Now, before we begin our learning journey, I want to start this session with an intention. So what is the intention that we have got, or what is my intention of creating this bootcamp? See, my intention is I want to give you, okay, I want to give you the AI Finisher Award. Okay, that's my intention. So I want you to succeed in this mid program challenge, and I want to give you the AI Finisher Award. So that is my clear intention, where I want to give you an AI Finisher Award where you will be getting certified in our AWS certified generative AI certified, and get the T-shirt from Manifold AI Learning. And also, I want each of you to get featured in this Manifold AI Learning community. So this is my intention of creating this bootcamp, because I want every learner in our bootcamp to succeed, and I want to give you all the help that is required for you to succeed in this examination bootcamp. Now, I can see few learners have joined from social media. So just to let you know, guys, this is the first session or the first class is free. So even if you have joined from social media, that's fine. So make the complete use of the social media, and you can like make the complete use of this first class. And whenever you're ready, you can feel free to join us. All right. So as I mentioned, I want to give you the AI Finisher Award. Now, this I'll be able to give you only when you get yourself certified in the AWS, like in the certification within 30 days. And I want to provide all the necessary help for you to get yourself certified in this AWS certified, AWS AI certified foundational examination that we have got. So that's the intention, guys. Now, with this intention in place, let's see what do we have for today's session. So here, as part of our learning journey, okay, so just to give everyone a quick background, so this is a boot camp which would happen every weekend. Like that means we'll have the session on both Saturday and Sunday. The timings are 5 p.m. IST to 7 p.m. IST. And the first class is today. And all the live session links is made available in the learning portal live.manifoldailearning.in. So I'll just give a quick demo on the same. We have already provided, but I can see few learners have joined in for the first time. Just go to manifoldailearning.in, click on sign in, and enter your email address. I'll just enter the email address. Now, once you log in to your account, you'll be able to see the silver membership. Go inside the silver membership or the course, and over there click on the course, and from here you can get the link for the class one, and you can click on this button join now to join the live session. So all the live sessions links are made available to you in the portal itself. Okay. And similarly, you also have a link for the class. So in this way, you'll be able to access the sessions. Now, important thing, I want each of you to join the WhatsApp group for notification. So we'll also be sending the important notification through WhatsApp. In case if you have not, uh, in case if you're not part of the WhatsApp group, go ahead and uh, join yourself. I'll just share it in the chat window right away. Okay. So I've shared the WhatsApp group joining link. Go ahead and click on that link to join the WhatsApp group so that you can receive the timely notification. Okay, we'll be posting the link, Zoom link in our WhatsApp group, and the links will also be available in online as well. So we are also coming up with a way to send the notification through email as well, so that you'll get the notification and you'll be able to join the sessions on time. Okay, this is a basic thing. So in case if you're having an issue, just post your queries in the WhatsApp group. So we have Sridhar from support team. So he has been assigned to help you in case if you have got any issues related to the access. Okay, now that this is clear, all right. So like in our learning journey, in the certification learning journey, so to ensure that you would succeed in your overall certification journey, we'll have an accountability system where we meet every week, we discuss on the progress, we'll do our best to clear any of the roadblocks that you might have got, and we'll celebrate the small victories. As I mentioned, we have the mid-program challenge. We also have an AI Finisher Award. So this is to celebrate each and every victories that you would get as you progress in the learning journey. And more importantly, yes, like you'll also be part of this weekly inner circle call for all the silver members. So you will be having the access to our weekly inner circle call so that you can join and you can we can discuss all the questions that you might have on your learning journey. Okay, so like the goal should be to get the most of this learning journey, attend the sessions live. Even though you will have the recording, it will be better if you can attend live and take actions about whatever that I would suggest in the classes. So ensure that you work on it over the week so that you are on track on getting yourself certified, and attend the inner circle calls on every Thursday and be respectful for others in the community. Okay, so those are the key things that I wanted to highlight. So now that this is clear, let's get started with our learning of this domain one. So if we look into the certification page, okay, so the examination is divided into 5 domains. So each of the domain is very important for our uh, success. So here, if I want to list down the domains, we've got the fundamentals of AI and ML, fundamentals of generative AI, application of foundation models, guidelines for responsible AI, security compliance, and governance for AI solution. So the first focus that we will be having is the domain one, that is fundamentals of AI ML, which carries 20% for the examination weightage. All right. So let's begin our learning journey with this domain one. So even though it has got the 20% weightage, this covers all the fundamental aspects that you should be comfortable with in answering the questions in this examination. And as I mentioned earlier as well, and I want to reiterate that our learning will be focused on getting ourselves certified in this AWS Certified AI Practitioner examination. Okay, that is our intention. All right, guys. So let's proceed ahead and let's get started with our domain one. Okay, so let's get started on this domain one team. Okay, just 1 second. Yeah. So here in this domain one, so as I mentioned, we are getting started with this domain one, that is foundations of AI and ML. So as I've already shown you, these are the domains in which we have to focus our preparation with. So the agenda of this overall domain is I'll be taking you through the basics of AI terms. the types of data, types of machine learning, how to align the use case with type of machine learning, the algorithms for machine learning, and what are the AWS managed services for AI and machine learning. And we'll also deep dive into the machine learning and some basics around this ML ops. Okay, these are the things that we would be focusing on as we proceed in this learning journey that is in this domain. Okay, so here in this scenario of this, like understanding this basic terminology, let's start with the AI. What exactly is this AI? AI is also known as the artificial intelligence. Now, this refers to the simulation of human intelligence in machines which are programmed to think and learn like humans. So it's basically a system where it has got an ability to think as well as to take the action. That's what an AI system is all about. So we say that these machines, okay, these machines can actually perform the task which typically require human intelligence, like recognizing the speech, and it can be understanding the natural language, it can be making the decision, solving the problem. So all these, okay, so all these are the capabilities of an AI or an artificial intelligence. Now, here, when we talk about this AI, it's about building a system. I just want to reiterate two things. It can analyze and take action. Okay, this is what an AI system can do. So to give you an example, I'll say Alexa as an example of an AI system. Why is it an example of an AI system? So I can say, let's assume that I'll say it as, hey Alexa, switch on the light. Now, when mention the command as switch on the light, the Alexa is able to understand my command and also take the action of switching on the light by doing some automation or by calling some program automatically. Based on what I've mentioned, it is able to perform this activity. So hence I can call the Alexa as an example of an AI system. So I hope you got a clarity as what is an AI system. It's a system which can analyze as well as take the action. Now let's talk about generative AI. Now, this is an important terminology which we are hearing these days. So let's understand, okay, what is generative AI? Now, when I say generative AI, it's a subset of artificial intelligence. And this generative AI focuses on the creating new or original content. So as the term, as you can see right here, there is generate. So generation means create something. So when I say generative AI, it's a subset of AI which is focused on creating new original content, like the chat GPT as an example. When you ask any question to the chat GPT, it will answer it in a way which it doesn't exist. It is like a tailor-made answer for the question that we have placed. So that's an example of an Gen AI system. That is the generative AI system. So that's what a generative AI system is. And it does this. Now, how does it do this generative AI? It does this by learning the patterns and the structures from the existing data. Now, when I say existing data, it will learn about the existing pattern from the text, images, music, whatever the data that we have given. Using that data, it will learn the pattern and then it can generate new things based on its learning. So using the knowledge, it is able to generate new output which resemble and extend the training data. So whatever that it will provide, the output that it will provide, it will provide the outputs which resemble or extend the training data. So that is what a generative AI system is all about. It's about learning the pattern from the existing data set and create new things. So it's just like what we humans do, isn't it? Like we'll prepare on one topic in the examination and based on our learning, we'll be able to answer new topics. We'll be able to create new content. So it's like an Like think about writing the lyrics for a song, which we generally do it as a humans, like creating lyrics or creating poems or writing a new paragraph. So based on whatever the learnings that we had, experience that we had, based on that, we'll be creating that content. So that's an example of the generative AI. Okay, so that's an example of this generative AI, guys. Okay, so all right. Uh, so now let's proceed ahead. Okay, just give me 1 second, team. Now here, now that you have understood the terminology of this generative AI, let's proceed ahead with the next terminology, that is machine learning. So what is machine learning? So machine learning is a subset of artificial intelligence. So when I say subset of artificial intelligence, it can do what a subset of what AI can do. So when we talked about AI, I've mentioned that it can analyze and take action. This is what an AI system is all about. Now, when I say machine learning, think of this machine learning as a subset of AI like this. So what it can do is it can only perform the analysis. So it can only perform the analysis for the given data set. The machine learning algorithms, what it will do is it will make use of our historical data. And using this historical data, it will learn the pattern and produce the new output values. And this is what a machine learning is all about. To give you an example for a machine learning, it's about, let's say we've got a spam filter, which learns to identify the junk email based on the past examples. So that's an example of a machine learning. Like what happens is here, when I want to talk about the spam filter, we will learn and we will understand as how does the spam data would look like. Based on the historical data, it will go ahead and learn this pattern. And based on that, we will be able to go ahead and perform the prediction as how it would actually look like. Like we'll be able to identify, let's say, junk mail based on the past data. So that's what we call it as a machine learning. It's a subset of AI which can only perform the analysis. Then you would come across another terminology that's called as deep learning. So what is deep learning? So deep learning is a subset of machine learning. Here, it uses a structure that's called as artificial neural network in order to mimic the learning process of human brain. So this deep learning, it would be apt to say that this deep learning is actually inspired by our humans itself. It is inspired by the way that we humans process the information. So we try to mimic as how we process the information using a structure that's called as artificial neural network. And using that structure, we will try to find the pattern in this given data set. And this is called as deep learning. And then I can say that this deep learning, one of the best part is it can learn from vast amounts of unstructured data. Now, traditionally, what would happen is as the amount of data increases, the machine learning models will become incapable of learning the complex patterns. But with deep learning, we can actually find the complex patterns in the given data set. Like to give you an example, we use this deep learning, especially in working with text data, image data, video data, like it is used in image recognition, which can identify the objects and the faces in the photos. So as you can clearly see, these are all the complex kind of data, that is the image or video data, or even the text as an example. These are all the complex data. It is highly unstructured in nature. Now, even to find the patterns in such unstructured data, this deep learning is very much efficient. So key thing that you need to remember in the case of this deep learning is we make use of artificial neural network. Then we have NLP. That's another term that you would generally come across. So in the case of this NLP is known as the natural language processing. So this natural language processing, it involves the technique where we focus on enabling the computers to understand, interpret, and generate the human language. And that's what this NLP is all about. It focuses on enabling the computers to understand our language. Like to give you an example, the chatbot can engage in conversations with the user. So that's an example of NLP. So we have talked about the various terminology. So let's have a quick recap as what AI, ML, and DL can do. Okay, that's one of the common questions of you would have. So let me have a quick recap around the same. So I've talked about the AI. So it can analyze and take action. So in case of machine learning is a subset of AI. It can only perform the analysis. Now, in the case of machine learning, we make use of a model that's called as statistical models. We make use of the statistical models to find the patterns in the given data set. And we have deep learning. Now, this deep learning is a subset of machine learning. So what it can do is it can perform only analysis only. It can perform only analysis, but here to find the patterns in the data set instead of statistical model, here we make use of artificial neural network. So this is the key difference between the AI, artificial intelligence, machine learning, and deep learning. AI can perform analysis and take the action, and machine learning can perform only the analysis, and deep learning can only perform the analysis using the artificial neural network. Okay, that's a core difference between the terms. Now, I just want to bring a point right here. When I talk about an AI, we have an analysis part. Now, in the AI system, to perform the analysis in the backend, I can either make use of machine learning or deep learning, which means in case of AI, I can either use machine learning or deep learning to perform the analysis, and I can write my software code to take the action based on the outcome of this analysis. Now, now that you have an idea of where the various techniques and the terminologies, I'll give you an example so that you can relate as how each of these terms are linked together. Let's bring up the same example, that is Alexa. Let's assume that this is my Alexa smart speaker. Now for this Alexa smart speaker, I'll give a voice command, say it as, "Hey Alexa, switch on the light." Now, what I'm speaking is, I'm speaking in my English language. So what technique am I using right now when I'm speaking in the English language to make the computer understand? I'm making use of the NLP technique, that is natural language processing, to make the computer to understand my human language. So it involves various steps. We will pre-process the data, ensure that it is represented in a correct format using NLP. Now, this pre-processed NLP data is then sent to either machine learning or deep learning to perform the analysis as what I'm doing. Like for example, I'm going to make use of deep learning model to understand as what is it that I'm trying to convey. So this deep learning algorithm will say as I'm trying to switch off the light or switch on the light. So that's the output from this deep learning model. Like for example, switch on lights. So this is the outcome of this deep learning. Now, once I have the output, that is switch on the learning, so switch on the lights. So based on this, the Alexa they have written some software where based on this action, they will perform an action. Maybe they will, let's assume that I'm making use of Xiaomi smart bulb. So it will call the function of Xiaomi smart bulb in order to switch on the light. So this is what the overall system would look like in an AI system. In an AI system, it will perform the analysis as well as take an action. Here, In this example, I'm making use of deep learning to perform the analysis. In the backend, it is making use of artificial neural network. If I'm dealing with text data, the NLP will also be used. So this is how all these terminologies that we have just talked about are actually connected together. So are you with me so far, guys? So if you're with me so far, please type in yes in the chat window. Okay, excellent. So thank you, Vijay. Thank you, uh, Vishal. Thank you, Dheeraj. Okay, excellent, guys. So now that this is clear, so let's proceed ahead and let's look into the next terminology that we have got. Okay, so Chandra, is it clear? So I hope I have answered your question now. Okay, and another question that that you might have is like, is ML is incapable of understanding the output of NLP? No, that's not the case. We can either make use of machine learning or deep learning, but what we have observed is deep learning has got the best ability to learn the pattern compared to the machine learning, and that's the reason we make use of deep learning neural network. But it doesn't mean that it does not have the capability. It's not much efficient. So that would be a best way to say this. Okay, now let's move ahead and understand about the next term that we have got, that's called as the large language model. So what is this large language model and why is it important to us? So when we talk about large language model, so large language models are basically the advanced AI models, and these have been trained on massive amounts of text data. Okay, these have been trained on massive amounts of text data, and it is capable of generating the human-like text. That means these large language models are also known as Gen AI models or generative AI models because it is about generating the text. So it has got the ability to generate the human-like text, and it can translate the language and even perform the activities such as answering the question. So when we talk about generative AI models or large language models, all those terms would mean the same thing. They are the advanced AI models. Here, the term large is being used because all these models have been trained on massive amounts of text data. So that's the reason the term large has been used. And we call it as a language model because it has been trained on a large amount of text data. And it actually makes use of the technique that's called as language modeling at a very high level. When I say language modeling, it has been trained such that given my current word, what would be its next word? Okay, based on this task of language modeling, the overall large language models have been trained so that it has learned the complex patterns in our text data. And since it has learned the complex pattern, it can also have the ability to generate the human-like text. And that is what the large language model is all about. Like to give you an example for large language model, we've got Gemini, we've got Bard, we've got ChatGPT. So these are all the examples of the large language models. Okay, so what we have just understood is we have understood about the different terminologies, that is AI, machine learning, deep learning, and we have also talked about the large language model and the NLP. So AI can perform both analysis and action. Machine learning, analysis, deep learning, also the analysis, but with the artificial neural network, the LLM is a large language model, which has been trained on large data set, and it has learned the complex pattern in a large data set, and it is now able to generate new data. That's what the LLM is, and NLP is a technique that we will use it in order to work with the text data so that the machines can understand. So these are the key terminologies that you need to know from the perspective of the examination. Now, we have learned about the basic terminology. Now, the next thing that we are going to learn right now, it's called as the types of data. Now, all these techniques, that is working with the data, working with the model, and performing the analysis of the same. So all these models that we have got, in order to perform the analysis, we make use of the data set. It is very important that you understand the various types of data. So let's understand the various types of data that we generally deal with. So these are the common types of data that we generally deal with. And it's very important that you understand what each of these terms would mean. In the examination, these are the terms that you would come across, and you should be familiar with this terminology so that it is much simpler for you to answer the question and even eliminate the incorrect answers. So the first type of data that we call it is a labeled data and the unlabeled data. So let's start with the term itself, that is data. So what is data? Data is the collection of facts. The collection of facts is an data itself. Okay. So for example, let's say I'm going to collect the temperature of the environment every 1 hour. Now that's a fact that I'm collecting for every 1 hour interval. And that actually is a collection of the facts. And that exactly is a data. Now, under this data, we have labeled and unlabeled data. Now we call this as labeled and unlabeled data, depending on the structure of the data. So when I say labeled data, this is a data where we have both features and target. When I say features and target, it has got our expected input as well as the expected output. To give you an example, let's say I'm collecting the data where I'm interested to predict the airline prices. Like I want to predict the ticket prices for the future days. Now let us assume that if that is the task where I want to predict the ticket prices for future days, in the historical data, if I have the information about ticket as well as the price. Now, when I say information about the ticket, I'll have the information between from to type of a ticket and what is the airline. And I also have the information about the price of that individual ticket, historical price. Then that is an example of a label data. Because here in this case, I have the information of both feature and the target. Now, this target is also called as label as well in some cases. So features and label, when I have both features and label, I'm going to call the data that we have got as a labeled data. Okay, we'll call this data as a labeled data. Then what we have is also called as the unlabeled data. So what is unlabeled data? Now here in this case, I just have the collection of information. I just have the collection of information or features about the data. Now on this data, I want to perform the analysis. Then we call that data as an unlabeled data. Okay, it's an unlabeled data where we just have the features and we do not have a target. So in such scenario, we use it as an unlabeled data. For example, if I take up the same airline example, I just have the information about the tickets, okay, like from to airline and maybe class of ticket like economy, premium, first class, business class, and so on. So if those are the features that we have, and I do not have any information about the price, I'll just go ahead and perform the analysis of these 4 or 5 columns that I've got, and I'll try to find the pattern in this given data set itself. Now, this kind of data is called as the unlabeled data. Okay, it's called as the unlabeled data. Then we call the data as a tabular data. Now, tabular data is a kind of data where we have the data that can be structured in the format of rows and column, where each row has the fixed set of column. Like for example, if this is my data set, if I've got 1, 2, 3, 4, 5 columns, each and every row has got 5 columns. Okay, so this is what we call it as a tabular data. Sometimes we call this tabular data as a structured data. We call this as a structured data. Then we also have something called as time series data. Now, what is time series data? Time series data is a special kind of data set where it's the collection of data where data has been collected at fixed interval. Like the example that I gave earlier for the definition of data, if you remember, I have mentioned that I'll be collecting the data of the temperature every 1 hour. If I do that collection for data every 1 hour, and if each and every row over here represents that individual temperature value, then that is an example of the time series data. Like for example, on 1st of like 10 a.m., what is the temperature? 11 a.m., what is the temperature? 12, 1 p.m., 2 p.m., 3 p.m., 4 p.m. So if I do the collection for every 1 hour, which is a fixed interval, and collect the data, then we call the data as a time series data. And this tabular and structured data, both are the same, where we have the data represented in a row and column format. And we also call it, we also have another type of data that is an unstructured data. Now, these are the special kind of data where I cannot arrange it in the format of rows and column. To give you an example, the text data. The text data is a clear example of unstructured data. Like for example, if I have two sentences, sentence one that says as, hello, how are you? And you have a sentence two that says as, movie is bad. So you can see that the first sentence has got 4 words and the second sentence has got 3 words. Now, in such scenario, it's very difficult to put it inside a table, like because the first row will have 4 columns and the second row will have maybe 3 columns. And it is very difficult to arrange it. I'll have to come up with a way to ensure that each and every column represents the same value. So those are all the challenges that we would have when we are dealing with this text data. Hence, we call this text data as an unstructured data. Even the image data in one scenario, like we can think of it as an unstructured data. So these are all the types of data that we generally deal with whenever we are working with our like techniques. Okay, so we have a label data. Okay, we have an unlabeled data, we have tabular data, we have time series data, and we also have the unstructured data. All right, so now that you have understood the types of data, based on the type of data that we use it, in most of the scenarios, based on the type of data that we use it, we actually classify the machine learning. So right now, you have understood about the data and the basic terminology. Now let's proceed ahead and understand what are the types of machine learning. Now, when we talk about the types of machine learning, we have 3 types of machine learning. One is supervised machine learning, unsupervised machine learning, and reinforcement learning. Now, understanding the difference and figuring out the difference is very important because you can easily score 1 or 2 questions easily by understanding just the difference and the definition. Okay, so focus on this closely, and this, like, it's a very simple topic and you should be able to understand the difference. So let's start with the supervised machine learning. So in the case of supervised machine learning, here, what we will have is the label data set. What we have is a label data set. So using the label data set, we are going to learn the pattern. So it's like using our machine learning algorithm to read it from a textbook which has got the answer keys. We have both features as well as the target. So in this case, we call it as a supervised machine learning. Then we have unsupervised machine learning. Now, in the case of this unsupervised machine learning, what we will have is we will have the unlabeled data. So we've already talked about the definition. Labeled data is where we have got features on the target. Unlabeled data is where we have only features. Okay, like to give you an example, you can think of this unsupervised learning as a detective who is trying to piece the clues together without actually knowing the solution beforehand. Now, we also have the another type of learning, that is the reinforcement learning. Now, in the case of this reinforcement learning, the algorithm learns by interacting with an environment. So it learns by interacting with the environment, and it will receive the rewards for penalties, like a robot who's trying to navigate the maze through trial and error. That's what you can think about as a reinforcement learning. It's a kind of a system itself where it will interact with the environment and figure out the best path. Okay, that's the scenario of this reinforcement learning. So let's understand each of these type in detail. When we talk about this supervised machine learning, here in the case of the supervised machine learning, the overall idea is we want to predict or classify the output based on the labeled input data. That means we will have an historical data which is labeled in nature, where we have got both features and the target. So using both features and target, we will try to predict the target based on this given features. So that's what the overall learning process it will be involved in the case of this supervised machine learning. Now, the way this is going to work is in this given scenario of the supervised machine learning, whatever the machine learning algorithm that we choose, it will be fed with a pair of input data and the corresponding correct outputs, which we also call it as the labels. So feed in the input data and the corresponding output labels, and the system will learn to map these inputs to the outputs. The system will try to map the inputs to the outputs, that is our features to target. From the historical data, it will learn to map these features to the target. So as a result of this, it will learn the pattern and it will be able to generate the prediction on the new and the unseen data set. To give you an example for the task of the supervised machine learning, like predicting the emails as spam or non-spam, predicting the house prices based on the features of house, identifying the objects in the images, whether it can be cat or dog, and so on. So those are all the examples of the supervised machine learning. Here, the important thing is we will have a label data. In the examination, you can expect a question saying as you're trying to build an application where you're trying to predict whether the person is going to click on the ad or not. Now, in such scenario, what should be that what you should have in your data set? So let me repeat the problem statement. The problem statement is, will customer click the ad? Okay, that's a question that you can expect in the examination. Now you'll have the option. For example, the option A, what you need to have in the data set. The option A says that you need to have the information about the, let's say, customer usage, customer profile details. Okay. And option B says that you need to have the uh, like let's say customer demography details. And you need to have, let's say option C says that customer uh, previous click details, or I'll say not previous click details, I'll say customer usage patterns. And the option D says that uh, historical customer profile with their click information. Okay, so these are the four options that you would have in the examination. Now, what is the problem statement? You want to predict whether the customer will click the ad or not. Now, in this scenario, which is the right option that you have to choose to answer this question? So just think about it. I'll give you a few seconds, think about it, and keep that answer with you. And then I'll explain the solution. All right, I hope you have made a choice. So the correct answer is D. Why is it? Here, I want to predict, okay, I want to predict whether the customer will click the ad or not. So if I want to do this activity, if I want to predict whether the customer will click the ad or not, which is like classifying the outcome, okay, which is about classifying the outcome, okay, which is about classifying the outcome as yes or no. Now, in order to do this, what I would require is a labeled input data. When I say labeled input data, I would require the information about the customer profile. It can be my input and their click information, which will is their expected output. Hence, the correct answer is D. If you look into the other options, we have the customer profile details. Now, when I say customer profile details, it's just the customer details that we would have. It's just the information about the customer. It's not possible for us to predict based on the customer profile. So in case if I want to do it, then it will be an unsupervised learning. And I cannot predict it whether the customer clicks the ad or not if I have just the customer details. Similarly, the usage pattern and the demography details, like these are all just the data points. But if I want to detect the output, then in such scenario, we'll be requiring the label data set. So this is the kind of question that you can expect from these definitions in the examination. Okay, so that's the scenario here, team. Okay, so all right, so here the spam that you see here, this is just I think it's an animation video that has been added in the backend. That's all. Okay, so uh, that's the overall idea about the supervised learning. So in the case of the supervised learning, what we will be doing is we will refer to the pattern in the given data set and trying to predict the result. Next, let's move on and let's look into the next learning technique that we have got, that is the unsupervised learning. So in the case of this unsupervised learning, we'll be working with the unlabeled data. So we just have only features and we'll be working with this unlabeled data and we'll try to discover the hidden patterns or structures. So what happens in the case of this unsupervised learning is here we'll try to find and analyze this unlabeled data and tries to find the meaningful groups or the pattern. So that is a scenario of this unsupervised learning. Here we are trying to find the meaningful groups. Okay, so that's a scenario of this unsupervised learning. And when we talk about this unsupervised learning, we have the example task such as the grouping the customer into the segment. And we have another task such as finding similar news articles, anomaly detection. So all these are the commonly performed tasks in the case of this unsupervised learning. To give you an example question as how does the question would look like in your examination. So here in the examination, the question would appear as you want to classify the credit card customers, or I'll say you want to group the customers, credit card customers, based on their profile and usage pattern. And you are dealing with the unlabeled data set. Now, in such scenario, which learning technique which learning technique is preferred? Option A, you will get an option as, let's say, unsupervised learning. Option B will be supervised learning. And option C you'll be getting as reinforcement learning. And maybe the option D they'll say mention as deep learning. So this is the type of question that you would get. And based on the learning that you have just had, the correct option is A, that is unsupervised learning, because here you're looking at grouping the credit card customers based on some pattern that they have mentioned. So assuming that this is an unlabeled data, the correct answer is unsupervised learning. Okay, so this is what we call it as the unsupervised learning. So we have learned about the supervised learning, and we have also learned about the definition of this unsupervised learning. Then we have something known as the reinforcement learning. Now, in the case of a reinforcement learning, what it will do is here in this case, the system will try to learn the optimal actions. Okay, the system will try to learn the optimal action so that uh, 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 so that like it can maximize a reward signal. Okay, so that it can maximize the reward signal. That is what the reinforcement learning is. The way this is going to work is here in the case of this reinforcement learning, the algorithm interacts with an environment. And what it will do is it will take actions and it will receive the feedback in the form of rewards or penalties. And it learns to take action that lead to the most cumulative rewards. Okay, that's what the reinforcement learning is all about. Here, what it will do is, like, for example, let's assume that the car that I'm highlighting right now, assume that this is a self-driving car. That's an example of reinforcement learning. So what it will do is when it is driving in the road, when it is getting trained, so it will try to take various actions or various kinds of steps. Based on its past experience, it will learn to behave it in a right way while it is traveling in the road. So that's an example of reinforcement learning. Here, it will happen through the experience. Okay, it will happen through the experience. And in the backend, we have the reward and penalty. This reward and penalty is what is the one that will drive the same. Okay, what that reward and penalty is the one that will drive the uh, element to the right solution. Okay, that's a scenario of this reinforcement learning. So we have talked about the supervised machine learning, unsupervised machine learning, and reinforcement learning. And we have understood that what kind of data will be used and what is the difference between these terminology. Like to give you an example for reinforcement learning, the kind of question. So the question would appear something as you're working with a data set, like you are working with an agent and you want the agent to automatically improve itself through like as and when the training proceeds. Now that's an example of reinforcement learning technique. Okay, so these are all the type of learnings, machine learnings that we have got. So in the learning journey that we have had so far, so let's open up our examination guide and let's see where we are right now. Okay, so if we review our examination guide, so our learning so far is in the domain one, we have understood the key terminology. And there are a few more terminology that is computer vision and other stuff. We'll talk more as we progress in the learning journey. We have understood the difference between them and we have understood the types of data. And we have also described the various types of learning that we have got. Okay, so those are the key concepts that we have learned so far in our domain one. Now, let's take a short break. We'll take a short break of, let's say, 7 minutes. Now, once we are back from the break, we'll continue with our discussion, guys. I'll start the timer. And in the meantime, if you have got any questions, please feel free to let me know. Now, once we are back from the break, so we'll deep dive and understand some of the like we'll deep dive and understand some of the concepts. Like I'll say the concepts inside this machine learning. We have got classification and regression. I'll take you through some of the important definitions around it, and I'll take you through the important algorithms under this classification as well as regulation, and then we'll proceed ahead. And by the time we complete today's call, that is today's session, we'll understand the definition. Okay, we'll try to understand the definition of these AWS managed ML AI ML services, so that at the end of today's class, so we'll be covering our basics, and we'll also build our I'll say knowledge on the various services that we have got in AWS. So that will make us in a good position for our next class. So let's meet after 7 minutes, guys. Okay. There's one more question about bias and fairness that we will discuss. That would come under uh, like at the later part in our learning journey, Abhijit. Okay, team. So we have learned the basics and we have learned some of the important things and the definitions about the artificial intelligence, generative AI, machine learning, and we have understood the basics. Now, let's proceed ahead and now let's understand about some of the types that we have under this machine learning. So to begin with, we have something known as the classification. So let's understand what exactly is this classification task and what are the types of classification and what are the algorithms that we have under this classification and how do we evaluate the models for classification. Okay, these are the key aspects that everyone needs to know when we talk about the machine learning. So let's start with classification. What exactly is this classification? In the case of classification, what we'd be doing is we'll be assigning the data points to predefined categories. Okay, we'll be assigning the individual data points into predefined categories. So what we do is we'll create the decision boundary that creates or that separates the classes in the feature space. Okay, that's what the overall classification is all about. Like, suppose if I've got 10 data points with me, suppose if this is my data set and if I've got data points with me, I want to classify each and every row to one of the class. Class is nothing but we have got the set of labels or set of names that I want that I'm having, predefined names or categories. We'll be assigning each and every row to one of the category. So that's what we call it as the classification. So we will learn these kind of patterns in this given data set, like it can be a addition boundary that separates two classes. And then if we get any new data, we'll predict the class based as to which boundary it would lie upon, whether it would lie near the class A or class B in this example. That's what we call it as the classification. It's about assigning the labels, predefined labels for the given data set. Now, under this classification, we have various types. So first type is called as binary classification. In the case of this binary classification, we'll have two possible classes or two possible predefined categories like yes, no, true, false. So when we are dealing with these kind of scenarios, we call it as the binary classification. And we have another kind of classification that's called as multi-class classification. Now, in the case of this multi-class classification, we will have more than two classes. Okay. In this case of more than two classes, we'll have the examples such as types of flowers, image recognition. So these are all the common types of classification where we have more than two predefined categories. Okay. And we also have multi-label classification. Now, in the case of this multi-label classification, each data point can belong to multiple categories. So that's called as multi-label categories or multi-label classification. Now, to give you an example, so suppose if you want to uh, classify the customer as whether it is the high customer or low customer, that is premium customer or an economy customer. If you want to classify a customer as two types, then it will be a binary classification. Suppose if you want to classify a customer as higher like economic customer, premium customer, or premium economy customer, where you have more than two classes, then it's a multi-class classification. In the case of multi-label classification, where let's say you have got a document and you want to assign the category, like the category can be technology, category can be machine learning, deep learning. So let's say you are assigning two or three categories for the same document. That is an example of multi-label classification. So these are the types of classification that we have in the machine learning. So what is it? It is dependent on the type of classification is dependent on the target or the output data. Depending on our target or output data, we are classifying each data point as whether it is binary classification, multi-class, or multi-label. If I have two classes, binary classification, more than two, it is multi-class. If I'm assigning multiple labels for same data, then it is multi-label classification. Now, to perform this task of classification, okay, to perform this task of this classification, so we have various algorithms. These are all the commonly used algorithms for the task of this classification. From the perspective of examination, it is important that you understand the name of this algorithm and what is the intuition behind this algorithm. It's very rare that you will be asked in detail about it, especially in this generative AI examination. So if you just know the name and its intuition, that is more than enough. So in the generative AI, like you will not be asked about, okay, you're dealing with the machine learning and how many number of trees or like trees that you need to create, or what are the hyperparameters that you have in the decision tree. I mean, that level of question have not appeared with any most of the learners that I've interacted with, and also I personally haven't come across the same. So if there is any change in future, definitely I'll be adding that information. For now, with the experience that we have had, so it's important that you understand the intuition behind it. If you understand the intuition behind each of these algorithm, that should be enough for you to clear this examination. The first algorithm that we have got is the logistic regression. Now, this logistic regression algorithm is going to is generally used for the task of binary classification. So we also call this as a probability-based algorithm. The reason is the output from this logistic regression will be between 0 to 1. So based on the values between 0 to 1, we'll be classifying the data as whether it is 0 or 1. Okay, it's a probability of a data point that is belonging to a class. So this is called as the logistic regression algorithm. And we have and just even though it provides the output between 0 to 1, this logistic regression can also be extended for multi-class classification as well. So technically it is possible using the techniques such as 1 versus 1 or 1 versus rest. I mean, this is for additional information. How we can use this binary classification model for multi-class classification. But generally, what you can remember is, okay, it is used for both binary and multi-class problems as well. And the other algorithm that we have is the support vector machine. So in the case of the support vector machine, what it will do is it will find the hyperplane to separate the classes. Now, when I say hyperplane, think of the previous example that I've shown. So let's suppose this is one data point belonging to the class P, and this is another data point belongs to the class A. The line that you would see right here, which separates both class A and class B, okay, that line that you see right here, so this is called as a hyperplane. Okay, this is called as a hyperplane, which separates the classes A and B. Okay, so this is the idea about how does this support vector machine is going to work. It will create a hyperplane which will separate the data. And the best part is it works well with high dimensional data. Then we have another kind of algorithm that's called as decision tree algorithm. Now, what it will do is this will create a tree-like structure from the given data. So it will go ahead and split the data into multiple branches on the basis of decision. And then like this, okay, I would go ahead and create the decision tree over here. Okay, so we will have a root node and we will have a child node. We will have leaf. So these are all the various properties of this decision tree. For you to remember, just think that it will split the data to make the predictions. Okay, so this is an easy to interpret and easy to visualize. It will create a tree-like structure. It is easy to explain what is happening in that algorithm when it is finding the pattern. So this is the idea about this decision tree algorithm. And then we have something called as random forest. Now this random forest is a combination of multiple decision tree. So we make use of multiple decision trees together to find the pattern. That's called as the random forest algorithm. And then we have naive-Bayes algorithm. This is also a probability-based algorithm, and it is based on the Bayes theorem. It is based on the Bayes theorem of conditional probability. And it assumes there is an independence among the features. So these are all the various algorithms that we have got for classification. We have got logistic regression, we have support vector machines, decision trees, random forest, and naive-Bayes algorithm. Okay, so these are the various types of various algorithms that we have got. Okay, so using these algorithms, now let me just define and what exactly is an algorithm. Okay, I've just defined the various algorithms, right? At a very high level, what is an algorithm? An algorithm can be an equation or a technique that is used to find the pattern between the feature and the target. So to learn the relationship between this feature and target, it can be an equation, it can be a technique. This equation or a technique is what an algorithm is. For example, for the logistic regression, the equation is y is equal to 1 over 1 plus e power minus z. For support vector machine, it will have its own pre-processing technique. For decision tree, it's actually a technique of construction of trees such that the loss gets minimized. And for naive-Bayes, it's actually the conditional probability, like probability of A given B is equal to probability of B given A divided by probability of B multiplied with probability of A. So this is an equation that is being used for the naive-Bayes. So this equation or a technique is what we call it as an algorithm. We use such equation to establish a relationship between our features and the target. And in the case of our classification, our target is basically a categorical in nature. It can be binary classification, multi-class classification, or multi-label classification. So that's the idea about the machine learning algorithms that we have got. Okay, so using these machine learning algorithms, we will find the patterns in this given data set. Now, I'll give a background as how it actually works. Okay, so this is to give you a better picture as how everything would work. For the demonstration purpose, I'll pick up a data set. Let me just open one of the data set that I have in my system. Let us assume that this is the data that I'm dealing with. I have various columns in this data set. I have sepal length, sepal width, petal length, and petal width. And I also have the information about the column of species. Now here in this data set, what we have been given is the column A, B, C, D that you see right here. These are all the features. Okay, these are all the features. And the column species is a target, which is the output that I want to determine. So in every data set, so they will clearly specify, or we will come to know from the problem statement as what is the input and what is the output. So in this data set, the first four columns are my input, that is my features, and the last column is the target. So I want to establish a relationship between this features, that is column A, B, C, D, petal length, petal width, sepal length, sepal width, all these four columns to my target column, that is species. And to find the pattern, I'm going to apply the machine learning algorithm. Now, when I'm generating the output from the machine learning algorithm, I can take any machine learning algorithm, but I'll just give an example. Let's assume that to learn this pattern between these four features and the target, I've made use of one of the algorithm, let's say decision tree algorithm. So in the backend, I'll be making use of the decision tree and I'll create the tree-like structure to find the patterns in the data set. Now, once the pattern has been learned, now what we might have is we'll have a step to generate the prediction. So we'll have a step to predict as what would be the output. Now, in that case, okay, in that case of a prediction of target, okay, in that case of prediction of target, so here, uh, the output that we would get from the machine learning model can be different than our existing output, that is our expected output. The column E is a target, which is nothing but the expected output. I'll say expected output. Okay, the column E is an expected output. Let's assume that the output from machine learning model, I'll say output from decision tree, is something like this. The output from decision tree is maybe in place of Setosa, it is predicting as, let's say, versicolor. In some cases, it is doing a mistake. So my intention is the output from decision tree should be same as the expected output, but in some cases, it is doing the error. Okay, in some cases, it is doing the error as you can see right here. Let us assume that it has done the error for first few rows and it has predicted correctly for the remaining rows. So I have predicted correctly for, let us assuming that for the remaining rows. Now in such scenario, okay, so when I compare the output from the decision tree and the expected output, there are some rows where we are doing the incorrect predictions. So to measure how well the output from my model would look like or how well the model is generating the output, what we generally make use is the evaluation functions. Okay, we make use of various evaluation functions or evaluation techniques to help us understand as how well the model is generating the output. So let's understand. Okay, let's understand as how can we actually perform the evaluation for these classification models. So when we talk about evaluation of the classification model, that is comparing our expected output and the predicted output in order to perform the evaluation, see, what we have is the accuracy. It is one of the commonly used metric for measuring as how well the model is generating the output. Here in this case, okay, accuracy is nothing but it's a proportion of correctly classified instances. Okay, it's a proportion of correctly classified instances. That is what we call it as the accuracy. It's a proportion of correctly classified instances. Like for example, if I have 100 rows, okay, and if 80 rows are correctly classified, then it's a proportion 80 by 100, which is nothing but 0.8. So which is nothing but the 80%. So the accuracy is called as the 80% accuracy. It's the proportion of correctly classified rows. So that's what we call it as the classification. Then we have something called as precision. So here, in the case of this precision, okay, it's a ratio of true positives to the sum of true positives and false positive. So this is what we call it as the precision. So it's the ratio of true positives to the sum of true positives and false positive. Like like the question is, what is this true positives and what is this true positives and false positive? We'll come to that very shortly in the confusion matrix. For now, let's look into the definition. Okay, like definition is actually important, and that's the reason that I'm showing you right here. And another definition that you need to know is the recall or sensitivity. So it's a ratio of true positives to the sum of true positives plus false negative. And we have an F1 score, which is the harmonic mean of precision and recall. So these are the commonly used metrics, especially when we are evaluating the classification models. So while describing the precision and recall, I have made use of terminology that's called as true positives, false negative, false positive, and we also have true negatives as well. So what are those and how can we learn? So all those are the metric that we would be getting under this confusion matrix. And we also have one more metric under the classification that's called as area under the RUOC curve. So this is one of the technique that we use it to measure the performance of various classification thresholds. In such scenario, we make use of this AUC ROC score. Now, all these metrics, especially all these metrics that you would see right here, is generally calculated with the help of this confusion matrix. So let's understand what exactly is this confusion matrix. So the reason that we use this confusion matrix because simply using the accuracy will not provide us the required information about the performance of the machine learning model. The reason because when we take an accuracy as an example, like for example, let's consider the Excel sheet that I have opened. So in total, we have got 150 rows. Okay, in total, I have got 150 rows and total correct values. Okay, total correct values are, let's say, 145. So 145 by 150, let's go ahead and calculate the accuracy. If I calculate the accuracy of 145 by 150, I'm getting the accuracy as 96.66% of accuracy. But this is not telling me as in which case the mistake has happened. Like for example, in this case scenario, the error has occurred for the case of Setosa. For the remaining classes, I do not see any error. Now, this level of this level of information is not actually available in the scenario of this accuracy. Hence, we make use of the other metrics, or hence we actually make use of this confusion matrix. So it will help us to get the clear understanding as in which scenario the model is actually making the mistake. So it will help us to identify that. And based on that analysis, we'll be able to take the further step. And this is especially critical for decision making, and it will guide the optimization. It will help us to choose the right evaluation metrics for the required task. So that is the reason that we actually make use of this confusion matrix. Okay, so here one is it's like the accuracy cannot explain completely about our data set. We'll not be able to get the insight, and it's also important for decision making to have a metric which is better than accuracy. So when we talk about the confusion matrix, the way we construct this confusion matrix is something like this. Along the rows, we will have the actual labels. That is our expected actual labels or the expected labels. Along the columns, we have the predicted labels. So generally, we construct this confusion matrix for binary classification that will give us a much better way to visualize as how does the model would work and look like. And we divide this table into 4 quadrants. We have true positives, we have false positive, we have false negative, and true negative. So these are the 4 quadrants that we would represent. Okay, now the reason that I'm showing you this confusion matrix because in the examination, I have personally got the question. It's like in the examination of both generative AI as well as in the machine learning associate PDA examination. In both the examination, I got a question about how do we actually calculate, or like tell me the definition of precision in one examination. In another examination, I got the question as, tell me the definition of the uh, like recall. Okay, that like both of the definition I got in each of the examination. So precision is true positives by true positives by plus false positive, and recall is true positives plus true positives by true positives plus false negative. So it's important that you understand the elements of this confusion matrix. Okay, so here when I say true positives is a case where I'm expecting the output as 1 and I'm also predicting the output as 1. That's a case of true positive. Okay, and in the case of true negative, I'm expecting negative, that is 0. I'm also predicting negative. That's the true negative. Okay, the values along the diagonals are the perfect values where my expectation is matching the prediction. And if you look into the other values that you would see right here, okay, so we have false negative and the false positive over here in this scenario. Okay, now in the case of this false positive is a case where it's it's a negative, but it is getting predicted as positive. And we call this as a type 1 error. Type 1 error is nothing but the false positive. In reality, okay, in reality, it's a negative, but it is being predicted as positive. And we also have a type 2 error. Type 2 error is a case where in reality, it is positive, but it is getting predicted as negative. That's called as a type 2 error. So type 1 error is false positive and type 2 error is false negative. So when you are going for the examination, ensure that you remember this table so you can easily score 1 or 2 marks from this table itself. So most of the learners that I've interacted with, most of them have got 1 or 2 questions from this confusion matrix. And like even if you don't get it on the confusion matrix, what you would get is the interpretation of the confusion matrix, which I'll be taking you through very shortly. So it's like I am iterating again that this concept of confusion matrix is important for your examination. Okay, so this is the anatomy of this confusion matrix. Now I'll give you an example. Let's say you have a spam filter and you want to evaluate its performance. Then you will make use of this confusion matrix, and this will help you to understand as how your spam filter is classifying the example as whether it is a spam or whether it is missing the spam or whether it is incorrectly flagging the legitimate email as spam or so on. So these are all the information that you'll be able to get once you create this confusion matrix. Okay, now the way that you would interpret this confusion matrix is, so you'll have the high precision and let's say you have got high true positive and high true negative. Okay, if you have the highest value for both true positives and true negative, that means if you have the values along the diagonals as high, then it would mean that the models is actually performing well in an overall way. That's how you would interpret this confusion matrix with high true positives and high true negative. And if you have the highest false positive, then what it would mean is the model is over predicting the positive class. So if you have high false positive, I'll bring up the sheet earlier. See, where is false positive? Here. If you are getting this highest, that means you have more number of rows which is predicting positive. That's how it would mean. That's what it would mean when we say it as false positive, like high false positive. And when you have high false negative, the model is under predicting the positive class, or in other words, the model is predicting most of the classes as 0, even though it's 1. So this is called as the high false negative. This is how we interpret the confusion matrix. And the other things that you need to remember is, okay, this is this is something that you need to remember from the formula itself. So if you look into the true precision. Okay, precision clearly says that true positives divided by true positives plus false positive. That means the model is intending to ensure that we are reducing the false positive. That is, we want to reduce the type 1 error. If I want to reduce the type 1 error, then I'll be looking out for precision. And the model doesn't care about false negative. See, at least when I say model, it is nothing but the equation, the metric that I'm using here. Okay. So the precision doesn't care about false negative. If I'm concerned only about false positive, then precision is a choice. If I'm concerned only about false negative, then sensitivity is a choice. That is a recall. So recall or sensitivity. So that's how we interpret it. So if I want to focus on reducing the false negative, then recall is the metric. If I want to reduce the false positive, then precision is the metric. Now, if I want to have a balanced metric, we'll take a harmonic mean of both precision and recall, which is basically our F1 score, which we have defined earlier. Like now that you have learned about the confusion matrix, see, precision is the ratio of true positives to the sum of true positives and false positive, and recall is the ratio of true positives to the true positives plus false negative. F1 score is an harmonic mean of precision and recall. So these are the key things that you need to remember when we are discussing or when we are thinking about the various metrics that we have got, especially from the confusion matrix. Okay. Now, the applications of confusion matrix, and this is important that you need to remember because most of the questions will be around this application itself in the examination. So almost all the questions that you would be getting in the AWS certified generative AI certification is all the questions, I'll say 90% of questions will be based on a scenario based. Okay. Like most of the questions will start as you are an AI engineer working in a firm and you're working on, let's say, an healthcare domain, and you want to minimize the false negative. Okay. You want to minimize the false negative. So in this scenario, which metric do you actually prefer? So you'll have the options: precision, recall. You'll have the option as F1 score and accuracy. So which one that you would use it? So if your task is to minimize the false negative, then let's just remember your confusion matrix. If you want to minimize the false negative, then you will prefer the recall. See, this is a metric that is focused on reducing the false negative. Okay, now let's take a look into the second example. So in the like as a generative AI engineer, you or as an ML engineer, you're working on a false fraud detection system, and you want to ensure that you want to have a balance between the false positive and false negative. Like you want to have a balance of both precision and recall. Then in that scenario, which metric do you prefer? Now in that scenario, you will make use of F1 score. F1 score is what you would prefer. Okay. And you will come up like they'll come up with one more scenario where they'll say it as, okay, you're working on retail and you want to ensure that you want to minimize the false positive. So if you want to minimize the false positive, which metric do you actually prefer? If you want to minimize the false positive, the metric that is responsible, that is helpful for us to reduce the false positive is the precision. Okay, so this is how the questions would appear. And in this way, you have to remember these concepts. It's not just the definition, it's about for a given scenario, which metric is actually chosen. That is what you will be tested upon in the examination. Okay, so let's do one thing. Now that we have talked about all these things, okay, let me just give you, okay, let me just give you clarity as like what kind of questions that you can expect overall from the learning journey that we have had so far, that is from the discussion that we have had so far. So what kind of questions that you can expect? So now we'll talk about it and then I'll take you through the important services in AWS. So I'll just give you some more examples. Okay, I'll just mention it in the slide itself so that you'll have it as a reference at a later point. So let's say you want to predict, okay, you want to predict whether the customer likes the product or not. So the question would something like it will start as you are a machine learning engineer and you want to build an application to predict whether the customer likes the product or not. Now, in that scenario, what is the type of machine learning will you be using? You'll have the option as supervised machine learning, unsupervised, reinforcement learning, and maybe time series analysis. So what do you think is the right answer? Okay, so what do you think, guys, will be the right answer if I want to predict whether the customer likes the product or not? So if I want to predict whether the customer likes the product or not, which is basically a categorical in nature, I want to yes or no based off question. Okay, it's a supervised learning. It's a supervised learning. That's correct. Then the other question that you can think about it is you want to, you are working, that question would start something as you're working as a machine learning engineer in the marketing department, and you want to categorize the customers based on the existing data. Now, in this scenario, what kind of technique will you be using it? Whether it is supervised, unsupervised, or reinforcement learning. Here, when I say categorize, it's more about grouping, categorize or grouping from the existing data, and there is no label present. Now, in this scenario, what kind of learning that we will be preferring? Think about it, guys. Yes, in this scenario, it's an unsupervised learning. That's correct. It's an unsupervised learning. And you'll have one more question that says as you're trying to build a system where you want the agent to improve as and when it gains the experience, as and when it gets more data through experience. Then in this scenario, what kind of data is suitable or what kind of learning technique will be? That's correct. It's a reinforcement learning. It's a reinforcement learning. Okay, so this is a quick recap about the types of learning and what the on the basis of each of these type, the other kind of questions that we have already discussed is under this classification, you can clearly expect the questions around the evaluation metrics of this classification model. And it is one of the crucial aspect in our examination syllabus as well. If I take you through the examination syllabus, understanding the model metrics such as accuracy, AUC, ROC, AUC, F1 score, and how do we actually interpret it from the business standpoint. Those are the crucial aspects of our of your preparation from this domain one. Okay, and what we have also learned is at a very high level, what are all the algorithms that we have got to perform the task of this classification. And we have also understood as how we can map the given scenario to a type of machine learning. And we have also understood the basic definition of the terms like machine learning, AI, deep learning, and the differences between them. Okay, so that's the learning journey that we have had so far. Now, before we end this module, like we'll continue further in our upcoming module in the same domain. But before we end for today, so let's understand about these services that we have got. So if you just understand the services and how it will be used, you can easily solve 3 to 4 questions. Okay, you can easily solve 3 to 4 questions. So let's go through these services and that will be a good way to prepare yourself. Like what you would be doing right now is you have prepared some of the core topics. Now you're trying to expand your knowledge on the fact-based ones. So what you have learned is knowledge-based. Now these are all the fact-based questions that you would get. So Amazon Transcribe. So let's understand what is this Amazon Transcribe. So Amazon Transcribe is a service that we have in AWS, which will help us to convert speech to text. Okay, it's a service that will help you to convert speech to text. So the kind of question that you would get is, I'll give you an example that I gave earlier itself. Okay, you are building an Alexa-like system or a voice assistant. Okay, you are building a voice assistant which is based on, let's say, generative AI, and you are getting the data in terms of voice. Now, you want to first feed this voice data into the generative AI. Now, which service will help you to convert the voice data into a text format? That's a question that you would get. And the answer is Amazon Transcribe, because this is a service which is specialized in converting speech to text. So once you have it in text format, then you will apply the various text processing technique to convert it into a vector format to feed to the generative AI. But to convert this speech or the voice that we would get from the human to convert into the text, that's where the transcribe would come into picture. So transcribe, remember, transcribe means speech to text. Okay, so the advantages is extract key business insights from customer call, because you are actually getting the text from the data that you're getting. It can be video file, clinical conversation, it can be anything. Wherever you're getting the speech, you want to convert it into that language. Speech to text is one of the best part about this transcribe. Another thing that you need to know is, so you need, like, it will ensure the customer privacy and safety by masking the sensitive information. This is an important point to know. And what I would highly recommend is, I highly recommend you to check out the complete page that you would see right here. You can click on this, learn more about Amazon Transcribe. Just go through this page and understand and get the most information that is possible from this page. Okay, that should be the goal whenever you are doing the preparation. Then we have Amazon Translate. Like as the name clearly says, okay, it is helpful for us to perform the fluent and accurate machine translation. Like the question that you would get is something like this. Your work as an AI engineer, you're working in a project where you're dealing with the text from, you're dealing with audio data from multiple languages. Okay, you're dealing with the audio data from multiple languages. Now, in such scenario, how do you transcribe or how do you convert the words or like text that you're getting it from one language to a common language so that you can apply the machine learning? So if you're getting the data from different languages, L1, L2, L3, so you'll pass all those data to, let's say, translate service. Okay, now this will convert it into a common language, let's say English. Then you will use that translated data, that is text data, into further processing. So that's the role of this Amazon Translate. So as you can clearly see, each and every service I'm giving you with an example as what kind of questions that you would get. The same kind of questions is what you can expect in the examination. So don't think like you'll get a definition based, like even though it says as a foundation level, the practitioner. So I'll say it's associate, or in some cases, the questions are related to the professional level. So for a foundation level, it's actually the tricky. So the kind of questions that you would get in the examination is the same type that I'm describing right now. You'll have a scenario. Based on that scenario, you'll be getting the question. So it says that it will help you to localize the content for diverse global users and translate and analyze large volumes of text. Okay, that's the role of this Amazon Translate. Then we have got Amazon Comprehend. Now, this is one of the commonly used service. The question that you would be getting as, you're working with the text data as an AI engineer, and you want to identify the sentiment in the uh, text data. Okay, in the data that you're getting right now. Now, how can you, which service can help you to identify the sentiment? That's where the Amazon Comprehend. It's a NLP service that will help us to uncover valuable insights. So when I say insights, it can be the sentiment, it can be about the entities or the important elements that is mentioned by the user. So all those things will be identified with the help of this comprehend service. Okay, that's the role of this comprehend. It is helpful for us to to uncover the insights, like uncover the sentiment, uncover the important elements or important entities in a text data that is provided by this Amazon Comprehend service. Okay, and we have SageMaker. SageMaker is a fully managed service from AWS where we can train, and deploy the machine learning models at scale. So we'll deep dive as we progress in the learning journey. For now, uh, like it's a service that we have got in AWS, which has got amazing features inside this to help us to perform the end-to-end machine learning. That's what this SageMaker is all about. Then we have the Amazon Lex. So Lex is a service that we'll be using to build the bots and the conversational AI. Okay, this is for building the bots with conversational AI. Whenever you come across a question which is about bots and conversational AI, so in most of the case, the Lex will be the answer. Like if they ask about you're trying to build a application, like as an AI engineer, you want to build an conversational AI bot, then which service would you use? Then Amazon Lex. Okay. Then lastly, Amazon Polly. So Polly is the text to speech. So previously, the transcribe is speech to text, and Polly is text to speech. Like you have a text with you, and you want to you want the computer to read that text, then you'll be using the Polly. Okay, that's where the Polly will be used. So as you can clearly see, by combining the overall uh, by combining the various abilities, you can actually go ahead and build the solution itself. Like to give you an example, okay, so let's say you want to build an like conversational bot with voice support or with voice response like Alexa. Then what you can do is you can build the conversational bot with the help of Lex. Okay, for sending the data to the Lex from our voice, you will make use of transcribe. Like you will get the user input. Our user input will be voice. Okay, I'll say, hey, Alexa, switch off the light. That will be transcribed into the text. And this text will be sent to the Lex. And Lex will process this incoming text and it will generate the output into the text. This will be the text output. Now, to share the output to the user, I'll be making use of Polly that says as, hey, I have switched on the light. To generate the response from the conversational bot, I'll be using the Polly, which says as, I have successfully switched on the light. This is the voice output. Transcribe is processing of converting the voice input into the text, and Lex will process the incoming text and generate the response in the text. So that's how all these three services would fit in. And this is how you need to try to think more about it in these terms when you're preparing the examination. So I'll be talking more about these kind of questions as we progress in the learning journey. I hope you got the idea as how you should be approaching these services. It's not just the standalone, it's about how each of these things can be linked together to build an application. So as we progress, I'll also include the generative AI, AWS Bedrock examples so that like since you will be hearing about all these scenarios when you're in the examination, it will be much easier for you to answer those questions. So that is the whole idea, guys. Okay, so with this we come to the end of today's session on our first session on AWS Certified AI Practitioner examination, guys. So few things to point out. So ensure that you join the WhatsApp group. You'll be getting the class links over there. Okay, and uh, like ensure that you join the WhatsApp group, and also you'll be receiving the email as well about the session joining links. All right, guys, if you have got any question, please feel free to let me know. If you're clear, please confirm by typing in as all good. Okay, we just says November 5, no classes, right? So let's see what is November 5. What is special on this November 5? Any holiday? Okay, Chandra says, will I miss a lot not joining WhatsApp? No, nothing, Chandra, nothing else. So you'll be getting everything inside the portal. It's more of getting the class link. Okay. So, all right. So, okay. So to give you a background, okay. So the current plan is for 4 weeks. So when I say 4 weeks, so with the pace that we are going in, so we should be comfortably able to complete it in fifth and sixth will be second week. Third week is 12th and 13th, and fourth week is 19, 20. Okay. So yeah, I don't think so. We'll be having any calls in November. In case even if we execute like extended, we may have it on 19, 20, but 26, 27 as well. But I don't think so. We'll have it. So we'll see how we progress. I want to ensure that everyone will be able to follow along in this learning journey. We'll go in the same pace as we have been going, guys. Okay, to what extent AWS goes in deep about services? So like not in deep in terms of asking about the technical details, but deep in terms of applicability and integration. That's how the questions will be about, Abhijit. Okay, any other questions, folks? Uh, SageMaker, no, that's not part of the syllabus, Chandra. I mean, that's not required for the examination. So you can check out our YouTube channel. We have already created, I'd say, 3 live session. You can check out our YouTube channel, our previous live session. You can learn more about SageMaker pipeline, but it's not part of our syllabus. So I'll just touch upon what is SageMaker pipeline, which is enough for our learning journey. Okay, thank you, Chandra. Thank you so much, guys, and thank you so much for being so interactive. Okay, I hope I have answered all the question. If I missed any question, please feel free to let me know. Let's do one thing. Let me know by the next session. I just have to drop for the next call. But like if I missed any of your question, let me know in the next call at the start itself. I'll ensure that I'll address your question and then we'll move forward with the next agenda that we have got. Okay, so take care, guys, and the session will be automatically uploaded on the portal. You can just check after 1 hour, 2 hours. Once the encoding is completed, you'll be able to access it. Okay, and I'll also be providing the slides as well. Don't worry, you can use this for your preparation. So whatever that I'll be using as a resource, I'll be sharing you as well.